Hello folks. Today we're going to work on the calendar movement of a cool clock. This is a Welch spring regulator number 1. It looks like kind of a supersized version of a typical schoolhouse clock, but with this cool calendar thing in the middle. I picked this clock up at an auction recently, and this calendar movement is kind of hanging off the clock. The clock actually runs, and we'll take a look at that later. But I wanted to just show you the movement here, and then we'll do some casework to repair this, and then we'll look at the rest of the clock. The way that this calendar mechanism works is there is a metal rod that hangs down from the time movement that pulls on this lever, and then that advances our calendar. So it's a relatively simple design. It's not actually connected by the clock, anything other than that one lever. The main issue here is just this wood's falling apart. We need to glue up the pieces, and we'll get that off, and we'll take a look at the movement in a minute here. So with the back plate off, here is the movement. That's all there is to it. It's a little ratchet system with some leaf springs here. I think I've got the bezel removed as well. And that's literally it. So this advances, and when it gets all the way around, it'll advance the month. That's the sum total of this movement. Calendar movements are almost always in good shape because they don't ever move. They operate once a day rather than thousands of times a day of a regular clock escapement. And because of that, these are usually recommended to not be oiled. So I'm going to look at this carefully and see its condition, and I may throw it through the ultrasonic cleaner, but then that's it. This goes back together, and our work on this part of the clock is just casework. Addressing the lost material in the bezel is pretty straightforward here. There's basically two holes that need attention. This smaller one, and then this is the bigger problem over here. So the holes don't need to be perfect. They just have to be good enough to hold a screw. So I'm going to do a real simple repair on here, and that's just take a couple pieces of toothpick, and we're going to glue this in like so, and that's going to fill in enough of the hole that we'll be able to get a screw to hold there of a reasonable size. This larger hole right here is a little bit of a bigger problem, and what I did is I just took a piece of dowel and kind of whittled it down, and this is going to hit the camera here, but this will be able to fit in place here, and should be what we need to fill in that area, so again a screw will hold. The door is in a little worse shape than the clock. We can see some of these joints open up basically completely here. All of these are loose, just that it's the dowel inside that's actually holding this together. And you can see some of the cause of this problem was the whoever tried to get the calendar to stick just kept tightening this screw until the head punched way into this. Sometimes these are hide glue, and you can heat this up with a heat gun and maybe get it to re-stick. I just don't think I'm going to have success with this. I suspect at least one of these corners has been re-glued based on some goop inside. So I'm going to try to carefully separate these without harming the veneer any more than I have to. And I'm going to try to sand these, and then we'll re-glue the dowel and then re-glue the seams. All right, I'm going to modify my plan slightly. This corner is actually pretty solid. I think I can force some glue in here and get that to stick because I don't think this has been fussed with. If we look at some other corners here, these are clearly repairs. This is modern glue gooped in here. So I'm going to take this over to the belt sander and very gently get this off so we have a nice flat seam on both sides, being careful to not change the geometry of these miters here. I've done some work on all the corners that I could get apart, and just using a square here to hold this in place. You can see there are some pretty good gaps, and this is just how the wood has moved over the years. I think the challenge here is if I move this around too much, I could have problems getting this to fit back together. And also you can see kind of the area where the calendar mechanism covers, which is the worst part of these gaps. I do think I'm going to take a crack at tightening these corners a little bit. I'll be happy with partial improvement, but we've got a pretty good gap, especially on this joint and then on this joint. So I want to see if I can tighten that up just a little bit. Doing some careful sanding with the belt sander, I've got this one corner, maybe half of the gap taken out, which I think is maybe good enough for what I think I'm going to get to without getting in big trouble. And using the square as a reference, it looks like this corner is pretty tight. The big problem is up here. I'm going to take a little bit off of this corner, and I think that's going to pull in all of these other corners. And I'm going to continue using the square to make sure that I don't get out of whack either in parallelism or anything else here, because this does need to fit back in the clock. But a little bit more on this corner, and that might be good enough. I think this is where we're going to have to stop. There are enough flaws just in how the original miters were. You can see, for example, right here that the original miter didn't line up very well, and they just kind of sanded it off. And the more I mess with this, I think I'm going to either have to just recut all the miters, which is going to make this significantly smaller, or call it good. We've taken a lot of the expansion out here by trying to be real careful about removing the same amount of material in each corner here. So I do think this is a fair bit better than where we started. We do have one new problem, though, and that is a couple of the dowels that were there previously did not survive the sanding process. And like this one, for example, just broke off. So we need some way to reattach these, and I'm going to go with something that may not be completely period correct, and that is with the Festool domino. The challenge that we have here is any kind of redoweling will mean that we would have to make new marks outside the frame here, and I really want to avoid that. The advantage of a Festool domino is this actually goes just inside the joint like that, and that will lock this in place really nicely, and it will not reveal any repair from the outside of the clock. So maybe somebody takes this apart in 100 years, they're going to complain that I used a 21st century joinery technique here, but I think it is going to be the right choice for not leaving marks outside the frame here. There's a lot of great things about the Festool domino system. One of the best is you only need one reference surface, and you can put a domino in and have the alignment come out right. If we look at how the door is constructed, we've got this decorative trim on the front, so it's not flat on the front. And actually, in this case, we've got a hinge that's in our way. So it's difficult to get something like this to lay flat, but we don't need that in this case because all we need is the reference surface on the top. The way that dominoes work is they align very accurately up and down, but they allow lateral movement like this. So the way that this is often put together is you put your seam together and you just draw a line across where you want the joint to be. And then when you cut your domino, you have a little bit of ability to adjust that so it's a nice snug fit. Here's a Festool domino tool, and how they work. There is a reference surface here which goes on our reference surface that we discussed before. And the tool works by plunging a cutting tool into the material. You can see the blade there. And this tool oscillates in this direction, and that's what cuts the slot for the domino. So to use this tool, I'm going to take my pencil mark, which is a little hard to see from the camera, but it's right here. And I'm going to align that on this reticle here. I've got a line right there. And then I just plunge the tool in, and that's going to cut a slot where this mark is, and then I do the same on the mating surface here. And because of this plate reference, it's going to be a really close alignment at this, so the components of the door are going to lay flat with each other. But as I mentioned a moment ago, there is a little bit of lateral play so that the domino can slide as we work on alignment. Here is our first domino. You can see how the slots fit together. This lets us get a very good matchup on the front here, and then we can adjust our corner fit a little bit to make this come together. So I'm going to finish those up, and then we'll get our squaring jig out and we'll glue this together. Here's our final fit up in the squaring jig. I've got very, 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 very light pressure on these clamps just to kind of hold it in place a little bit. And this is the one blind corner that happens to fit together pretty well, so that makes sense to be in the squaring jig on that side. And it isn't perfect, but it was not perfect initially. So we're going to put some glue on this, and that's going to be good enough for this clock. I've got some wax paper to catch any glue bleed on the bottom, and we'll let this cure overnight, and then we can get the calendar mechanism back in. Putting this back together, there were two holes that I marked as okay, meaning I didn't do any filling of the bezel below because the holes were in fairly good shape. So what I did is I put screws in here which will index these two pieces together. These two holes I did repair on the lower bezel, and so we do need to drill that through so we can get our new screws in. And the clock had screws of kind of an odd length. This is about 0.85 of an inch. And modern screws that I can find are either a little shorter than this or a little longer than this. And what I'm going to do is I'm actually going to just convert this to a modern. This is a number 4 by 3/4 inch screw. The holes in this clock are recessed a bit, so the head of the screw actually fits a fair distance down in the hole. So we're going on the shorter side than the longer side. I have set up the drill with the bit in the chuck so that I can't drill too far, but we'll still go easy here. We'll drill these out, put these screws in, and then hopefully we can get this back together without causing any visible damage on the front side. That went pretty well. So now we have the metal back plate of the calendar mechanism. I had to shave this a little bit with the chisel because as we brought the pieces in, the cutout for this hole shrunk a little bit, and this didn't quite fit here. So I just buzzed a little bit off of that with the chisel, and I think we're in good shape. A couple screws here, put the lock and the hinges back on, and then we'll get to see it on the clock. Here is the front side of the calendar mechanism that we worked on, and we've got the date of the month as well as the months on these two hands. On the main dial, we have the time on the large hands, and we have the day of the week on this smaller hand here. Forgive the paper clip that I'm using to hold this door closed. I have a little bit of a hinge spring issue that I need to work on. This is what the clock looks like on the inside of the middle. We have a double weight time only drive. You can see there are two winding arbors here. It does not have any strike or chime. It's just two weights for time. And we see this strap that hangs down with a notch in it. This is what catches our calendar advance lever right here. And what happens is it actually pulls up. And so if I advance this manually, there we go. And we can see that the months advance with the date. We were near the end of a month there. And so we saw the hand moving toward the next labeled month on the small hand. And then as we go around again, every click moves one day. This is a nice design where the calendar mechanism is self-contained and it's simple to actuate. Some other calendars that I've worked on are a lot more complicated to navigate because there are wheels and other levers. All of this is just a relatively simple set of gears that all lives inside the door of this calendar mechanism. It's very cool. I don't know if you noticed this, but this is a perpetual calendar where it knew that November only had 30 days, and so our hand actually skipped from 30 to 1 on that advancement, that single advancement. That's really a neat feature. I've got the bezel open here, and the time right now is set to a little bit before 4 o'clock p.m. And what's going to happen as I wind the clock forward is this lever is going to rise very slightly. If you look at the damage to the label in the back, you can see that as kind of a gauge as this goes up. So there we're going up. We're at about 8 p.m. right now. Oops. There's 10 p.m., 11 p.m., and then midnight. So it's as high as it goes there. And now we show about 3 a.m. Continuing to wind the clock, and now we can see that lever is lowering very slowly. I'm at about 7 a.m. right now on the time dial. And this continues to go down. So this is not a snapping mechanism. It is just a very gradual cam that raises and lowers this lever. And so that's it. That just hangs off of the back of movement on a simple cam, and that actuates this calendar lever here. which advances our calendar 1 day at a time, with the calendar being smart enough to know how many days are in a month. Here's our clock with the dial off. We can see right here, this is the standard minute and hour wheels. And this is a 24-hour wheel. It's got twice as many teeth as this. So it goes around once every 24 hours. And this is connected to the rod that goes down to the calendar mechanism to advance that. It's very simple, very elegant. If you notice this clock, the escape wheel is on the bottom. That's a little unusual. The winding arbors are at the top. It's not a very big movement relative to the size of the clock. It's a kind of a normal sized movement, maybe a little bit bigger than a Seth Thomas number 2. The pendulum is hung from the case, and we can see that our crutch wire in this clock does something kind of crazy. And there's actually 2 places for the crutch wire to go to. I don't know why that's there. I don't know if that was some kind of modification sometime in the life of this clock, but you can see the crutch wire is very bent in this clock. That is not super uncommon for that to be the case, but it seems like it'll be long enough to go into that lower slot. If you look at the escape pallets here, you can see that this is not a strip pallet movement like in less expensive clocks. This is a machined anchor, and it's just kind of a nice feature, and it's unique again that it's at the bottom of the movement. And we can see here are 2 winding barrels. The cable goes up to a pulley at the top of the clock and then down on each side for the weights that drive this clock. Here is the dial off of the clock, and you'll notice that the day of the week hand actually stays attached to the dial in this clock. If we turn this over, on the back we see a 7-toothed star, and this is actually what drives that day of the week hand. This is concentric with the hour and the minute hand, and this is driven off of this same lever that drives the calendar mechanism. I think this clock is really interesting how efficient they've made this to drive all these extra functions. Both the calendar mechanism and the day of the week run off of just 1 extra wheel. This is hardly any different from a standard time-only movement, but yet they've managed to add all that extra functionality. One last engineering detail as I reassemble the dial. You'll notice this hand is actually counterbalanced. It is large enough that they've taken the time to actually put extra weight on the back to balance out the length of this hand. I hope you've enjoyed riding along with this really large and really cool calendar clock. Thanks for watching.